Hello friends, this is Gangadhar from the YouTube channel Maths Ganga. Today in this video I am going to discuss about the few applications of the amazing distributive property. And this is the second video on the smart calculations. In the first video of smart calculations, I mentioned the distributive property and the way of utilizing distributive property in calculating the difficult multiplications by converting into easy additions and subtractions. And I suggest you all to watch that video also along with this one. Right? Now in this class, so using distributive property, how to get the results for the multiplications, I am going to discuss certain models of. Okay. See, for example, if I have a number, something like some 78 into 11. Okay. See, 78 into 11. 78 into 11 can be written as, using distributive property, it can be written as 78 into 10 plus 1. 78 into 10 plus 1 is nothing but what? 780 plus 78 into 1 is 78. And you will get it as 0 plus 8 is 8. 8 plus 7 is what? 15. And then 7 plus 1 is 858. Okay. So 78 into 11. And for suppose if I have that 78 into 101, then what will happen? Since if I am going to multiply 78 into 101. Okay. See, this can be written as 78 into 100 plus 1. 78 into 100 is 7800 plus 78 into 1 is 78 and the result is 7878. So without doing all this thing, directly we will mention that 78 into 101 is 7878. See, if you observe, okay, the cases where it happens, the cases where we will announce the answer directly. If you observe it, since 78 have 2 digits, okay, and this 101 is 10 square plus 1. So if we are multiplying an undigited number with a number 10 power n plus 1, the result will be in this manner. Okay, now observe it. What I am going to do is, first suppose if I have 78 into 101, the result is directly 7878. Okay, in the same way how we calculated 78 and 78, using the same way we will announce the answers for these type of questions. Something like 149 into, since I have 3 digits, then I need to take 10 cube plus 1. So something like 1001. Then the result is nothing but 149, 149. In the same way, for suppose if I have a number having 4 digits, 7263 into is 4 digits, and I will take here 10,001. So if you multiply this 7263 into 10,001, the result is 7263 and then 7263. Okay, see, whenever we will say the answer like this, and if we multiply an undigited number with the number 10 power n plus 1, then directly we will say the answer as like this. Okay, see, 78 into 101 is 7878. 149 into 1001 is 149, 149. 7263 into 10,001 is 7263, 7263. So all it happens just because of the distributive property. Okay, so utilization of distributive property will give us these type of rules. Okay, now this is one type, one model. Okay, if you mention all these type is one model, then I will go to discuss another model. Right. Now coming to the second model, see, if you observe 78 into 101 is 7878. For suppose if I multiply 78 into 1001, then what happens? Since I am multiplying 78 with 1001, one more 0 is added. So then the result is 78078. Nothing but because of distributive property. How it happens? 78 into 1001 is nothing but 78 into 1000 plus 1. And if you multiply 78 with 3 zeros plus 1 into 78 is 78. and if you add, the result is this one. So 78 into 101 is 7878. 78 into 1001, 780 is 780. So 78 into 10,001, the result is 78, 2 zeros along with 78. In the same way, for suppose if I have 143 into 10,001, what will happen? See, if it is 3-digit number, if the number of zeros are 2, the number is 3-digit and the number of zeros are 2, then the result is 143, 143. But the number is 3-digit, the number of zeros are also 3. So the result will be 1430143. So directly we will announce by multiplying any number with 101, 1001, 10,001, 1,01,000. If you multiply any number with this type of numbers, we directly will announce the answer with the help of the distributive property. Okay, so now if you observe, take a number and then multiply in different manners, how it is become. Okay, see, this is the second model. Okay, multiplying a number having with the number having more number of digits in between 1 and 1, and this model is multiplying a 2-digit number with 10 square plus 1. Okay, all this is because of distributive property. If you are very familiar with the distributive property, if you feel very comfortable in using distributive property, then directly we will answer all these type of questions in fraction of seconds. Okay, right. And the next one is, for example, if I have 1, 2, 3, 4. If I have 1, 2, 3, 4, if I multiply this 1, 2, 3, 4, since it is a 4-digit number, so if I multiply it with 10,001, the result is 1, 2, 3, 4, 1, 2, 3, 4. Okay, just because of distributive property. By writing this one as 10,000 plus 1, multiplying 1, 2, 3, 4 with 10,000 plus 1, 2, 3, 4. The result is this one. So here we have 4 digits and here we have 3 zeros. So the problem is same. Okay. So in another one, for example, if you treat 786, here we have 3 digits. So we need to multiply a number having 2 zeros in between them. The result is 786, 786. Okay. For suppose if I raise one more zero here, then I will get 1 0 in between this 786 and 786, 7860, 786. If I raise one more zero here, okay, then the result is 786, 2 zeros, 786. Like that we need to keep in mind. Okay, for suppose if I decrease the number of zeros, how the answer will be changed? If I decrease the number of zeros, for suppose 1, 2, 3, 4 into 10,001 is this one. If I will decrease 1 0, 1, 2, 3, 4 into, instead of this 10,001, if I write 1001, how what will happen? See, we need to multiply 1, 2, 3, 4 with 1000 plus 1. So the result is 1, 2, 3, 4 into 1000 plus 1. And if you multiply 1, 2, 3, 4 along with 3 zeros plus 1, 2, 3, 4. Okay, so the result is 1, 2, 3, 5, 2, 3, 4. Since 1 0 is reduced, so these two 4 and 1 will get added as 5. The result is 1, 2, 3, 5, 2, 3, 4. Okay, just observe it. If the number of zeros are just 1 less than the number of digits, answer is 1, 2, 3, 4, 1, 2, 3, 4. See, if one more zero is reduced, then the answer is changed like this. We need to add this 4, 1, 4, 1. Okay, for suppose if you multiply 1, 2, 3, 4 into 101, then what will happen? One more zero is reduced. Since we reduced one more zero, then what is the answer? So if we reduced one more zero, the answer is 1, 2, 3, 4 into 100 plus 1, 2, 3, 4. 1, 2, 3, 4, I am writing this 101 as 100 plus 1. So 1, 2, 3, 4 into 100 is 1, 2, 3, 4 with 2 zeros plus 1, 2, 3, 4. Then what is the answer? 4, 3, 4 plus 2 is 6, 3 plus 1 is 4, and then 1, 2. 1, 2, 4, 6, 3, 4. Okay, how it happens? We have add that the last digits are same, the before digits are same. Okay, see, two zeros are reduced now. So we need to concentrate on this part. So if you concentrate on that part, 3 plus 1, 4 plus 2 will happen. Okay. See, if you memorize this one, directly you will answer. Okay. Otherwise, using the distributive property, you can answer. Ultimately, usage of distributive property will reduce our work in calculating in doing multiplications or in calculating the products. Okay. See, now observe what is happening. Okay. See, for suppose, if I have the number 1, 2, 3, 4. If I have the number 1, 2, 3, 4. If I multiply this 1, 2, 3, 4 with, since I have 4 digits, so I need to multiply a number with 3 zeros and 1, 10,001. So if you multiply this 1, 2, 3, 4 with this 10,001, the value is 1, 2, 3, 4, 1, 2, 3, 4. If I multiply this 1, 2, 3, 4, okay, by raising one more zero with the 4 zeros and 1. Since I raised 1 zero, the value will become like 1, 2, 3, 4, 0, 1, 2, 3, 4. And if I multiply the same 1, 2, 3, 4 with the number having 5 zeros and 1, then the result will be 1, 2, 3, 4, 0, 0, 1, 2, 3, 4. This is all just because of the distributive property. If I multiply the same 1, 2, 3, 4 by reducing 1 0, that means with 1001, then how the result will become? For this product, the result is this one. Since I reduced 1 0, then the result will become like 1, 2, 3. This 4 and 1 will get simplified as 5 and then 2, 3, 4. If I multiply the same 1, 2, 3, 4 with 1 not 1, then see, since I reduced 2 zeros, then we need to concentrate on the 4 digits in between there. Okay, so if you use distributive property, you will get your answer as first 2 digits are 1, 2, the last 2 digits are 3, 4, and just we did it. How it happens? Okay, 1, 2, 3, 4, and then 1, 2, 3, 4 now. So 1 plus 3 is 4, 4 plus 2 is 6, and this is the result. See, multiplying 1, 2, 3, 4 with these type of numbers, the result appears like this. Our concentration is basically on this number. What is this number? Multiplying an undigited number with the number 10 power n plus 1. Like this is 4 digit number. So we are going to we multiply with 10 power 4 plus 1. That means 10,001. So if you multiply a 4 digit number with 10,001, the result is like this: 1, 2, 3, 4, 1, 2, 3, 4. If you multiply a 3 digit number with 1001, that means 10 cube plus 1, the result is the 3 digit number repeated twice. Okay. If you multiply a 2 digit number with 10 square plus 1, that means with 101, the result is a 4 digit number with 2 digit number repeated twice. Okay. See, and then while raising the number of zeros and by reducing the number of zeros, the result changes like this. Okay. So this is all just because of the distributive property. Okay. So if you are very familiar with the uses of distributive property, then okay, this is all is very simple for us, right? Then another. Coming to the another one, for example, if we are going to multiply with something like some 101, okay, or some 78 into something like 101. 78 into 101 is not 11. 78 into 11 is nothing but 78 into 10 plus 1. 78 into 10 plus 1 is nothing but 780 plus 78. 8 plus 7 is 15 and 7 plus 1 is 8. Okay, so directly how can we answer? Since we are multiplying 78 with 1, 78 with 11, since we are multiplying 78 with 11, see, 8 once is 8 and then 7 plus 8 is 5 and then 7 plus 1 is 8. Okay, directly write this digit and then add 2 digits and then 1. For suppose if I have that 64 into 11, then what is the answer? First one is 4 and then 4 plus 6 is 10. So keep 0 here and 1 in our mind. Then 6 plus that 1 is 7. So 7 not 4 is your answer. And for suppose if you are multiplying something like 59 with 11. If you multiply 59 with 11, first of all write the 9 here and then 5 plus 9 is 14. So write 4 here, keep 1 in our mind and then add that 1 to this 5, the result is 6 and your answer is 649. Okay, so like this we will do the multiplications with 11. Okay, see if you observe, whenever it happens if you multiply a two-digit number with the two ones, that means 11. If you multiply a two-digit number with two ones, 11, then directly we will give the answer. Okay, right. In the same way, if you multiply a three-digit number with three ones, then also the same phenomena will work. For example, if I have a three-digit number like 342, and I am going to multiply this 342 with three ones, then what it is, 340 into 3 ones is nothing but 100 plus 10 plus 1. I am writing this 111 as 100 plus 10 plus 1. Since I am writing it as 100 plus 10 plus 1, then what will happen? 342 with two zeros plus 342 into 10 is nothing but 34210 plus this 1 into 342 is 342. So this is 2 and 4 plus 2 is 6, and coming to here 342. 342 is how much? 42 is 6 plus 3 is 9, and then 3 plus 4 is 7, and this is 3. So our answer is 37962. Okay. Since we are multiplying a three-digit number with triple 1, this is first is 2 and this is 2, and then 4 plus 2 is 6 and this is 6, and then add these 3, 2, 4, 3. 2 plus 4 is 6 plus 3 is 9, and this is that 9, and then again 4 plus 3 is 7, and then I left with 3. Okay, see, one way is observing like this, and the other way is directly using the distributive property like this. So 342 into 311, and then result will be 37962. Okay, so all this is because of the distributive property. For example, if I have a number like this, something like 135 into 10102. I need to multiply 135 into 10102. So without doing actual multiplication, I will use the distributive property. How it works? 135 into 10102 is nothing but 1 along with how many zeros? 1 along with 4 zeros plus, and then 1 along with 2 zeros plus 2. So multiplying 135 with this number is nothing but multiplying 135 with this summation. And then if you multiply 135 with this number is nothing but 135 along with 4 zeros plus 135 into 100 is nothing but 135 2 zeros, and 135 into 2 is, I know it as, and we know it as 270. And if you add 0, 7, 7, 3, 6, 1, 3, and directly our answer is this one, 1363770. That means distributive property changes the multiplication problem into the addition problem. Since we are very familiar with the addition, so the multiplication also become easy with the help of distributive property. So like this we will do different problems related different problems in the multiplications with the help of distributive property. Not only additions, okay, in certain situations we will convert the given multiplication into subtraction using the distributive property. Why it happens? For suppose if I am going to multiply a number 137 into something like, if I need to multiply this number with 19, how it happens? Since I am multiplying 137 into 19, I will write it like 137 into 20 minus 1. See, so this is 137 into 20 minus 137 into 1. 137 into 20, multiplication of the 2 is easy. So 137 into 2 is nothing but 274 with 1 0 minus 137 into 1 is 137. And we need to do subtraction. 10 minus 7 is 3. So we have 3 minus 3 is 0. 7 minus 1 is 6. 2603 is our answer. So in this type of situations, we will do the subtraction also. For example, if I have a number, okay, see something like 47 into 99. So to calculate 47 into 99, what we will do? 47 into 100 minus 1, which is nothing but 4700 minus 47. And then the result is 10 minus 7 is 3, 9 minus 4 is 5. So 1 is already borrowed. So this is 6, and our answer is 4653. Okay. See, uh, if the number of nines and the number of digits are same, like this, like 47 into 99. For example, if you take another number, something like 38 into 99. If you do, this is 100 minus 1. Then what will happen? 3800 minus 38. And the result is 10 minus 8 is 2. 9 minus 3 is 6. And then this is 7. This is 3. 3762 is our answer. Okay. So, for this type of problems, the direct observation is this is 8. Okay. So, 10 minus 8 is 2. So, how this 2 happens? And this 2 is nothing but 10 minus 8. And for the next number 3, how this 3 happens? And this 3 is 9 minus 3. This 6 is 9 minus 3. Then this 7. So, we are multiplying a 2-digit number with 2 nines. So, 2 digits are over. Then for the third digit, this 7 is how it happens. And this 8 minus 1. And then the next number is 3 as it is. Okay, like this we have to continue. Okay, for this number also, this is 7. 10 minus 7 is 3 here. This is 4. 9 minus 4, 5 is here. And then this 7 minus 1, 6 is here. Then the result is, next number is 4. 4, 6, 5, 3. So, whenever it happens, it happens if you multiply a 2-digit number with a number having 2 digits. With a number having 2 nines. So, for example, if I have a number something like 243 and I am going to multiply this number with a number having 3 nines. Okay, see what is the result? I will say the result is, since it is 3, 10 minus 3 is 7. This is 4. 9 minus 4 is 5. This is 2. 9 minus 2 is 7. And then 3 minus 1 is 2. 4, 2 is our answer. Okay, directly I will say the answer. How it happens? It happens just because of, if you observe, 243 into 999 is nothing but 1000 minus 1. So 243 into 1000 minus 243. So 10 minus 3 is 7. 9 minus 4 is 5. And then 9 minus 2 is 7. So already 1 borrowed, so I have 2 here, 2, and then 2, 4. So 2, 4, 2, 7, 5, 7 is our answer. So if you multiply an undistributed number with a number having n nines, then directly we will use this technique. What is the technique? Once again observe, this 7 is nothing but 10 minus the units digit 3. Okay, and then this 5 is nothing but 9 minus the second number 4. This 7 is nothing but 9 minus the third number 2. So 3 digits are over. Then the fourth digit is nothing but the units digit minus 1. Why? Because we borrowed one number now. So since it is 2. The remaining numbers are same. 2, 4, 2, 4. Okay. See, if I apply the same method for a 4-digit number having 4 nines, then what will happen? If you observe, take a 4-digit number having what? 4 nines. So if you have a 4-digit number, something like 4, 5, 6, 7, multiply this 4-digit number with a number having 4 nines. Then what is the answer? So directly I will say the answer as 10 minus 7 is 3. 9 minus 6 is 3. 9 minus 5 is 4. 9 minus 4 is 5. 4 digits are completed. Then this digit is nothing but 7 minus 1 is 6. And then write the 4, 5, 6 as it is. This is the answer. If you need, just check it. Okay. For example, if you go have another number, something like 727, you need to multiply this number with a number having 3 nines. What is the answer? 10 minus 7 is 3. 9 minus 2 is 7. 9 minus 7 is 2. 3 digits are completed. Then this units digit minus 1 is 6. 7, 2, 6, 2, 7, 3 is our answer. Okay. So this is happens just because of the amazing distributive property. So the distributive property reduces our work in calculating the products, our risk in calculating the multiplications. It converts the difficult multiplications into easy additions and subtractions, and in sometimes using the distributive property directly we will announce the answers by seeing it, just by seeing it. Okay, just by seeing directly we will announce the answers. Okay, so now I will give you certain numbers and how can we answer. Okay, for example, okay, if I have a number like 357, if you multiply this 357 with which number? 10 cube plus 1, that means 1001. How the result happens? Directly we will announce that as 357, 357. Okay, and if you multiply this 357 with one more 0, the result is 3570, 3570. Okay, this is one main logic what we discussed in today's video. And another main logic what we discussed in today's video is 357 into 999. Then what is the result? So 10 minus 7 is 3, 9 minus 5 is 4, 9 minus 3 is 6. 3 digits are completed. Then units reduced to minus 1 is 6, and then 3, 5, 6, 6, 4, 3. Okay, so these are the very useful and then needed the multiplications in different competitive examinations. Okay, see, just observe this, take your own problems and then use the distributive property to solve. Okay, and after solving, if you feel very comfortable and then if you feel an encouraging motivation to use in this distributive property, just ask certain questions regarding the distributive property to your friends also. Okay, see, just you just transfer your technique, you just convey your way of doing using the distributive property to your friends also. Okay, help everybody to solve the difficult multiplications with the easy additions and subtractions using the distributive property. Okay, so don't forget to subscribe to the channel. I hope this video is helpful for your preparation, and I hope this video raises your confidence level regarding mathematics. Okay, do like the channel and refer it to your friends also. Thank you.